Thank you for joining today's session, Top 5 Considerations for Successful VDI Deployments. My name is Sean Allers, and I am part of the Strategic Solution Architecture and Design Organization at HPE. I am responsible for end-user computing, solution design and architecture across the Americas, public and private sectors respectively. I engage with clients pre and post sales on a daily basis, touching 100 plus end-user computing opportunities per year. And I'm here today to share what HPE believes are important variables to consider before building out end-user computing solutions. And with that, let's get started. So consideration 1, identify business drivers and establish the use case for VDI. Identifying the use case is critical as it lays the groundwork for all other considerations that follow. There are a few factors to consider when determining the use case. Number 1, business driver. Be it security, business continuity, management. Understanding these drivers will set the stage for your workplace transformation journey. Secondly, while it is common to find a number of different use cases across organizations, task, productivity, power, or GPU accelerated, rarely are these users created equal. As such, understanding use case, virtual desktop, virtual application, GPU accelerated, persistent, non-persistent, will provide necessary variables begin characterizing the expected workload, compute, storage relative to the end user requirement. Further, use case, provisioning model, and VM profiles all require different resources from a compute node and storage perspective. Understanding these requirements will lay the groundwork and set expectations with respect to overall scope, utilization, and performance. Example, some users may require persistence, others may not, while others may benefit from application virtualization, GPU, or a combination of everything. Determining the use case and characterizing the workload are critical to understanding the hardware, software stack necessary to support it. Consideration 2, identify workload specifics and take a workload-centric approach to sizing. Once the business drivers, use cases, and provisioning models are established, the workload begins to take shape. Virtual workloads are defined by VM profiles, vCPU, RAM, application stack, image size, persistent or non-persistent, or even GPU requirements. So how does one define the workload? VM profiles. So how does one define a VM profile? Well, there are 2 ways. First is a thorough and full physical, virtual, or application assessment. This generally takes a minimum of 3 to 6 weeks of consulting engagement and trended data collection using workload assessment tools. This is a great path if you have the time to spare. However, if you don't, you're really left with only one option, and that is to run a proof of concept. Centered on real-world users, specific user images, and use cases relative to the defined VM profile expectations. VM profile is the basic for all node density projections, and critical for establishing node equilibrium with respect to hardware requirements, utilization, and performance. Example, a VM profile of 2 vCPUs and 8 gigs of RAM might achieve a density of 100 users per compute node relative to vCPU to core overcommits. However, the same VM with 4 vCPUs and 8 gigs of RAM may only achieve 50 users per compute node relative to vCPU to core overcommit. And what's that mean? It means twice the amount of hardware. Cost goes up. And finally, never overcommit RAM. Consideration 3 is all about determining scope and scale of the project. Understanding scale and scope in conjunction with use case and workload requirements establish ground rules for platform selection. As some platforms and architectures perform and scale better than others relative to workload or use case impacting hardware selection. So let's talk about scope first. It is important to understand how the workload will run across use cases and how many users the solution will be required to scale to. For instance, the economics begin to shift in favor of more traditional compute storage architectures at roughly 2,000 users and above. So number of concurrent users begin to dictate platform selection. From a scale perspective, you need to have a solid understanding of how deployment will roll out respective of whether it is a single site, multiple sites, or globally. An example would be WAN versus LAN access, local compute resources versus regional compute resources, etc. And finally, it is critical to define what the solution is going to look like during the initial deployment and 6 to 18 months from now, so that the scope and scale do not paint the solution into a corner because the selected platform does not scale. Moving on to consideration 4. This is platform selection. As I mentioned at the beginning of the presentation, the platform is dictated by the use case, workload, and scope information. Once these variables are firmly understood, platform choice tends to present itself, letting workload characteristics drive platform selection to avoid cramming square pegs in round holes. Number 1, HPE is an open systems company, offering a broad portfolio of end-user computing platforms to match specific use case, workload, scope, and deployment models. So looking at the slide, moving from left to right and starting with HPE Technology Solutions, HPE is positioned to address small to medium enterprise VDI solutions requiring persistent user use cases as an example. For a more traditional approach to end-user VDI using rack-based form factors, there are HPE ProLiant and Apollo servers backed by centralized storage, which typically traverse small, medium, and large enterprises. For use cases which require the easy button, DHCI and disaggregated hyperconverged solutions powered by HPE ProLiant servers and HPE Nimble storage provide similar ease of use and independent resource scalability as HCI. However, with the added benefit of HPE OneView composability. HPE Synergy is an established and proven platform and traditional architecture for end-user computing solutions using blade-based servers and back-end by centralized storage, typically traversing medium to large enterprises. For specific use cases where resource contention is a concern, HPE Moonshot, HDI, or hosted desktop infrastructure, provides a physical one-to-one resource to user for specific use case requirements requiring high levels of system responsiveness, effectively taking the desktop from under the desk and moving it into the physical data center with security and management in mind. Financial services, trader desk workstations, light to medium engineering design, and content creation are all examples of use cases for this particular platform. Regardless of the platform you choose to deploy, NVIDIA GPU solutions traverse the HPE portfolio of platforms and solutions, offering some of the highest densities per use case in the industry. Moving on to consideration 5, deployment models. Now that the first 4 considerations are firmly understood, the last consideration is around determining which deployment model works best for your business, organization, and/or budget. There are 3 deployment options available, including, but not limited to, the following. A private cloud. This is more of a traditional deployment of end-user computing solutions where hardware and software are located on-prem. This is a traditional EUC end-user computing model that can be CapEx or OpEx based. This model is particular interest for highly regulated industries, Fed, DoD, healthcare, financial, workloads which require emphasis on governance, security, and intellectual property concerns. Second option is a public or managed cloud model, desktop as a service, or pay-as-you-go model based on consumption. And third option is a hybrid cloud model consisting of all of the above, where the deployment spans private, public, and managed cloud environments. HPE offers all 3 models, including managed services, through HPE GreenLake. Now that we've discussed the 5 considerations, let's put them into action with a real client I'm working with. This particular client is a global engineering firm. They have 3 regional data centers, North America, EMEA, and APAC. They have a total of 1,200 engineering users globally, both virtual and physical compute resources, and engineering simulation and 3D visualization. The challenges include managing physical workstations and laptops across global regions, securing and protecting intellectual property across global regions. And finally, the loss of engineering productivity due to current WAN upload-download times, models, and assemblies. The requirements are GPU acceleration and the highest density that we could try to achieve for those particular users. Data, models, and assemblies, locality to compute resources, meaning Let's take the models and assemblies and move them as close to the virtual compute as we can, thereby minimizing the overall latency of the models, and also ridding the program of upload-download times over the WAN to specific workstations or laptops. The other requirement is the ability to address rolling dev cycles in 24/7 global operations. Along with that, ability to change personality of compute resources using scripting to address opposing workloads from within the same system, addressing two workloads with a single system. So what's the solution? In this particular case, through our scripting, as well as our GPU density and the ability to direct connect 3PAR all-flash storage to the back end of the Synergy platforms, we settled on HPE Synergy and Direct Connect 3PAR. Firstly, we ran a POC to determine workload specifics for GPU, VM sizing, and node density projections, setting the expectations with regard to utilization and performance for the client. This addresses GPU density and GPU acceleration with respect to both GPU presentation and GPU computational workloads. This also supports physical and virtual compute nodes, so I can have virtual and physical compute nodes in the same platform connected to the same storage. This also offers the ability to personality shift each individual compute node at will based on scripts. Centralized data and security and data locality with respect to compute workload performance as well. And finally, this folds neatly into existing DR, backup, and recovery topologies. Finally, it is important to understand that end-user computing is a transformational journey, bringing together multiple IT assets and organizations across the enterprise. Desktops, applications, servers, storage, and networking all have to come together to be successful for end-user computing. And while this is a daunting task, to be sure, HPE has the knowledge and experience required to help guide your organization to success. Further, HPE PointNext Professional Services provides a full scope of services, including advisory, professional, and operational services. We provide rationalization of applications, workloads, images, etc., to determine end-user computing readiness. Advisory services covering solution design, migration planning, image design, optimization services, and solution deployment, as well as management of change, bringing teams together to work together to make this end-user computing workload a success. And finally, from an operational perspective, HPE can also assist with flexible as-a-service consumption and managed service models through HPE GreenLake and HPE FS financial services organizations, helping you work through the financing of your solution. In summary, keep these considerations in mind. Clock speed is your friend. Watch your vCPU to core overcommits. Never overcommit RAM. Listed here are other sessions and demos taking place across the HPE Discover virtual event related to this topic, and I encourage you to check those out. In addition, you can find information on our HPE PointNext services, HPE GreenLake, end-user computing VDI platform information at the URL provided. And lastly, you can also follow us on social media feeds for the latest and greatest information. Thank you for attending today's session. Should you have any questions, please feel free to contact me directly at the email address on the last slide. And again, thank you for attending HPE's Discover virtual event.